Alright, let's look at the homework 5.2, 5.3, problem number 12. Alright, so we want to maximize this p function. You can think of it as a profit function, which is 3x plus 40y, 30x plus 40y, and subject to 2x plus y is less than or equal to 14, x plus 8, y is less than 8, and x plus 2y is less than or equal to 12, and then you have a non-negative constraint. Right? So let's do that. I'm going to do it all by hand. Right? So if you look at this problem, first thing we need to do is we need to sketch the feasible region or solution region. Right? So I'm going to have draw a y-axis here, and then x-axis here. Alright, and alright, so let's look at the first inequality. Alright, so think of it as pretend that this is an equality and you want to find the x-intercept, so hide y. So you have a 2x is equal to 14, so it's 7 is going to be the x-intercept. So I'm going to put maybe 7 right here. And so it's going to go through here. And the y-intercept is going to be 14. So 14, so it's going to be double that. So it's going to be around here. All right, 14 here. All right, then we just need to connect these two dots to draw the borderline. All right, something like that. All right. So that's the first one. So maybe I'll number this. This is the first one. All right. Second constraint. X-intercept is 8 and y-intercept is 8 as well. So we know that this is going to be, so 8 is probably right next to it. So it's 8 right here. And this is 7, so 8 is probably around there. So 8, right? So we connect those two. So this is that, and this is another one. So it's going to look kind of like this. Alright. Alright, so this is number 2. Alright, and third one is going to be, let's say, x-intercept is 12. So that's the biggest one here. So 8 is here, so 12 is probably around, maybe around here. So 12, right? And a y-intercept is going to be 2y equals 12, so it's going to be 6, right? So 6 is probably somewhere around here, right? 6, right? So we have a dot there and another dot there. And I'm going to connect those two guys together. Right, so it looks like that. I missed a little bit there. All right, then you can see that, I'll try 0, 0, the origin. Usually check this side. All right, so 0, 0 actually satisfy all three inequalities. So you have to shade the side that has the origin in it. And looks like we're talking about this region right here. All right. All right. So looks like we have a bunch of corner points. Corner points are, let's start with the origin. So that's actually a corner point, and this is another corner point. And looks like there's one here, and there's another one here. There's another one there. All right. Then what we want to do is we want to pick basically the corner point that makes this profit function the biggest possible, right? So let's pay attention to this profit function here. Right. So I'm going to solve for y so that I can determine the slope of the line. So first thing is I'm going to subtract 30x, right? So you would have negative 30x plus p is equal to 40y. Right, then we can divide through by, oh sorry, I said divide through. Right, we just need to divide through, let's see, divide through by 40 to get, let's see, negative 30 divided by 40 is 3 over 4, right? Just knock out zeros. So x plus p over 40 and is equal to y, right? So you can see that, let's see, negative 3/4 is the slope. So we have a slope right here. Right, so this is the slope. All right, so negative 3/4. Let's see, if you compare this, it's going to be steeper than this. Oh, actually, I didn't number this, number 3, because slope is actually negative 1/2 there. And the borderline number 2 has a slope of negative 1, because you go 8 units to the right and go down 8 units, so it's negative 1. So this negative 3/4 is not as steep as the second constraint, but steeper than third constraint, right? So we are looking at the slope, which looks kind of like this. Let's see. So so it's going to be in between. So maybe I should draw it like that. Maybe here. What color should I use? Maybe hey, let's use blue, right? So the slope negative 3/4 is going to be a slope which looks like this. Right? So, and you can see that since we're trying to maximize it, so we want to make this y-intercept as big as possible, so we're pushing it up. And the last point it's going to go through in the feasible region would be this point right here. Right? So this is going to give you the maximum value. So here is going to be the maximum value, right? So, but we need to find that point, right? So since this is an intersection between the borderline number 2 and the borderline number 3, so we have to look at these two guys, right? So the borderline number 2 and the borderline number 3. All right, so pretend that, so since we're talking about borderline, we can turn this into equation. So x plus y is equal to 8. Then we have x plus 2y is equal to 12, right? This is kind of convenient because we can just do the subtraction. All right, x minus x is 0, 2y minus y is y, and you have a 12 minus 8 is 4, right? And x can be found, just plug it in. So you have x plus, right, y is 4 is supposed to be 8 there from the second equation. So we can subtract 4 from both sides to get x equals 4 as well, right? So it doesn't look like it, but this guy has a coordinate 4, 4, right? So if you want to find the maximum profit, P would be, you just have to plug in x equals 4 and y equals 4. So you have a 30 times 4 plus 40 times 4, which is equal to 120 plus 160, which is going to be equal to 280. All right, so the biggest profit would be 280. So let's plug it in. All right, profit would be 280. So type that in and check the answer. All right, we got that. All right, then the coordinates are, it's going to be 4, 4. So it's a 4, 4. Check the answer. All right, that's it. I hope that this was clear.